Thanks to April and Nabila for that inspiring talk. I'm just going to have a bit of a chat about the audio product I'm working on that has a lot of Swift in it. I don't have it to show you because it's not finished, and it's also maybe a bit boring because it doesn't really make any sound of its own accord. It's very much a kind of utilitarian thing I wanted to build to use in my own studio. I mean, I'm hoping there's some interesting bits to talk about. And if not, you can tell me to hurry up. Anyway, I don't want to talk too much about myself, but I'm mostly working as a musician now. I kind of worked in IT for a long time and then decided to get back to music maybe about 15 years ago, so that's kind of my day job. But yeah, I kind of got bitten by a technology bug again recently, trying to work on this audio product, and I thought maybe it might marry two things that I'm interested in. A long time ago, I used to work with a lot of Next stuff. I don't know if you guys know Sean Woodhouse. I think he's a person about town. Anyway, Sean and I worked together in 95, 96 for a company in Australia that did a lot of Next Step stuff, and which was pretty unusual. And then when Apple bought Next, I ended up doing some stuff, bits and pieces of macOS. But that's all very old and probably doesn't exist in macOS anymore. But I've been enjoying playing with Swift, particularly since it was open sourced. Anyway, I'm just building this thing, and I've got like I've got a version of this is not the final thing. In fact, this one doesn't even work because it had some errors on it. But basically the idea is, and I don't know how, I presume this is more IT than an audio audience, so I don't want to go too much into the boring details about what the requirements are and how it works. But generally, as a musician, you're on stage or you're in a recording studio, and one of the really important things is to be able to hear yourself. In the old days, when you had a bunch of people just playing around a single microphone, that was pretty easy because no one was wearing headphones and everyone just balanced themselves acoustically, and that's probably how some of the greatest music was ever made. For one reason or another, that's not how things are done now, and people tend to wear headphones, and one of the important things is you have a great mix in your headphones so that not only can you hear yourself, but you can hear the other musicians with whom you're playing in a nice and balanced way. And it can be nice to have some control and autonomy over that yourself, because the cognitive load of yelling at the engineer to turn you up, usually it's you want to turn yourself up, when they might be trying to do a bunch of other things, is often not an ideal workflow. And most people are used to dealing with smartphones now. It's not too hard to turn something up or down. So the idea of this product, and it's certainly not a unique idea, I think maybe I just have doing it in a slightly nicer way, is to build something where the musician will have control over their mix themselves. It'll be low latency, so the time between when they strike the note and it gets captured and you hear it back in your ears is really low, and that's important for people's performance, particularly if you're playing a percussive instrument. Really, ideally, you want it to be under a millisecond from the time the sound hits the microphone to the time you hear it in your ears, and with a whole lot of things like a network and digital analog conversion stuff in the way, that latency budget gets eaten up pretty quickly. And yeah, another thing is that the audio is delivered over network, so that's kind of nice. You can mix both audio and control information together. You don't have to buy expensive things to distribute the audio. You just go to Officeworks and buy a network switch. Basically transfers some of the commodification of the IT industry, which is a big industry, into the audio industry, which relatively is a smaller industry, and lets you take advantage of some of those things. Been working on it for almost 3 years now, and I didn't think it was going to take this long, but it has. And it's a bit depressing because I haven't done as much music in the last couple of years. I also have a young son, so that's my excuse, but my real reason is I've been spending a bit too much time on this. Anyway, this is kind of how it started, with a bunch of messy boards. I should say I'm not really a hardware person. I don't really know anything about electricity. Can understand to the extent that it mirrors logic, I can understand it, but the closer it gets to actual electrons moving, I have very little idea. A high school physics student would know more than me. So I've made lots of silly mistakes, but I've had met lots of lovely people who've helped me out, and that's been really fantastic. So it just started off with a bunch of development boards, and you can see that user interface there looks pretty terrible. I think I showed it to Sean or one of my friends, and like, that's not actually the UI you're going to ship, is it? I thought it looked pretty good, but you know, it's nice and minimalist. But and yeah, the actual thing, I mean, I'll explain a bit more in a second, but yeah, it's just running in a Raspberry Pi. Again, there's nothing. This board itself is a custom board, which has all the audio stuff on it. But a Raspberry Pi compute module just slots in there, and the reason for that is that if you want to design your own, if you want to design that stuff actually into your board, and you have really high-speed things like RAM and stuff and Ethernet. Well, there is Ethernet on this board, but it gets complicated real fast and expensive, and you're going to make a small number of things. You're not going to save any money by doing that. The Raspberry Pi compute module is perfect for this kind of use case. And it runs Linux, and that's how I get to using Swift. I should also point out that there is now a dialect of Swift called embedded Swift, which strips out like a bunch of the runtime stuff to make it more easy to use on bare metal devices. That's not what I'm using. I basically need too many of the features that have been left out for that to be the case. And I've got an operating system, so you can just use Swift, the normal Swift. That was an early 3D printed prototype that I took to a trade fair last year, which, you know, it didn't work too well, but it kind of worked. It did unfortunately overheat in there, and I was wondering why like the CPU usage was going through the roof, and as soon as I took the case apart, because it only occurred since we put it in the case, which of course was done like the day before the show. Anyway, we will fix, I mean, obviously nylon is not very thermally conductive, something we'll fix. But you know, it's just so many little things. Like you want to have a display that's a bit nicer than the one you get with a Raspberry Pi, well then you're going to go to Alibaba and find, you know, get a bunch of quotes for some really high-res displays like you might find on a smartphone. That's great, but you're going to have to write your own kernel driver. All that stuff. None of it's like impossible. It's just, there's just a long list of things, and each of these things takes time, you know, sometimes a month, sometimes a couple of weeks. And all this time adds up, and that's how I still haven't finished. But on the right's kind of what it will look like. I don't think it's going to be pink, but it will look something like that. And effectively, this board is just going to be shrunk down a bit, so it's thermally a bit better, and so we can make the unit a little bit smaller. But you can see things like these connectors. That's where the Ethernet's supposed to be. But these things have quite a high internal profile, long internal profile, so you can't actually make it. If you're going to have plugs, you can't make it look like a smartphone with an edge-to-edge screen, because there's no, unless you're going to make it really tall, there's just no room for the things that have to fit inside it. The architecture, again, you know, it's probably a bit boring if you're not into audio protocols, but I'll just quickly draw the distinction that everything's remote controllable, so the user interface itself is just a client of this control plane, which is really nice, because then you can, if you've got a bunch of devices, you can automate or you can control them from somewhere else in the network. It means if you want to save, like recall and save people's settings, and that's easy to do. The device has got a couple of different independent headphone outputs, which you can see here. And you know, your buddy, she might have like a smartphone, control her mix from that, and you control yours from the touchscreen. And it's exactly the same, using exactly the same protocol. It's just that one UI is running over a domain socket and the other one is running over TCP. Also, I'll get to the UI stuff in a bit, but I made some choices to try and be able to reuse as much of that as possible. And then internally there's a daemon that accepts these control commands, and then it kind of fans those out to lots of internal protocols that just connect, that happen over like serial ports or SPI or I2C or whatever. That's just happening within the board. So that's not, that's kind of opaque to both to the UI and to any remote clients. Why did I choose Swift? Well, I guess because of I do actually wonder now whether it was the right choice, but you know, I'm pretty too far gone for that now. I think I have a bit of emotional attachment to Apple's technologies because of working with Next Step 30 years ago and kind of following Apple from when it was running Objective-C and stuff from when it wasn't so cool. So when Swift was open source, I wrote a few apps and stuff, and I just had a bit of fun. So of all of the kind of successor languages to C, it's probably the one I'm most familiar with. I don't really know anything about Rust, and my C++ isn't very good. Kind of like the fact you could develop on macOS, because it's kind of, in spite of what people say about Xcode, it's still a fair bit friendlier than developing just with, from the command line. Its Linux support's pretty good. It's definitely been getting better over the last few years. The things I don't like about it, I do like the async await stuff, and I've used that pretty heavily, but it's hard to debug. On the other hand, it's not really a criticism of Swift because any concurrent programming is hard to debug. You're just kind of shifting around where the pain points are. The binary sizes are pretty large. That's even when you build in release mode and strip everything, it's kind of a bit on the annoying side, particularly if you're on a constrained platform. It doesn't really matter with a Raspberry Pi because relatively the smallest ones still have got oodles of RAM and flash, but if you want to, there's some other product ideas where I would want to maybe use a 32-bit ARM and a much smaller and cheaper CPU, and Swift starts to become a bit of a problem there. Like there's one other, there's an FPGA on this board which you can load some custom firmware onto the Linux CPU that's part of it, but 4 megabytes is the most, the largest your image can be, and there's no hope of you couldn't even put Swift Hello World in that. The tooling on Linux isn't also great. Diagnosing things like memory leaks and retain cycles are hard anyway. At least on Mac, you've got some tools. The best hope is that you can duplicate those bugs on macOS and use Apple's slightly better tools, and then hope the bug doesn't recur on Linux, but obviously that really depends on where the bug is. And the other thing, to point out is that the Swift stuff is really just in the control plane, like the top half of this. Anything that's happening in real time is pretty much written in C. Not only could the chips that are running that code not support Swift, that would be a whole undertaking, but there's no real benefit to using a safe language. Relatively, the number of lines of code in that is small, but the amount of time spent debugging it is high, just because debugging real-time stuff is complicated and requires, it's very timing sensitive, as you'd think, and it's just, I don't think the language is really the issue. It's just more, I don't know, my lack of experience or the nature of the beast. You could use the real embedded Swift potentially on a, STM32 or something, but I didn't really need to see a reason to make things more difficult. I chose Swift for the bits where it was useful and not for the bits where it wasn't useful. There's a whole bunch of bits that I use Swift in, but I don't know, and I can give you a kind of a bit of a demo. I can't show you any audio because everything is so fragile that if I even look at it, it's going to break. So taking on the number 96 tram is not going to happen. But I can show you a little bit of a simulator. It actually may be a little bit of a good time to touch upon some of the UI decisions. So a simulator, well, running on Linux, there's just the control side of things. What happened? Oh, there we are. And that's just, obviously, it doesn't do anything. It's just running in Vegas mode where you get lots of blinking lights. But one interesting choice for the UI is I ended up using Flutter. I did a bit of a research rabbit warren into different things. There are a bunch of embedded UI frameworks that are around. They're usually written in C. They're pretty, code quality is not often that good, and they're pretty hairy. It's a bit like, it's great for resource-constrained systems, but the Raspberry Pi isn't really that resource-constrained. There are a lot of Swift UI clones, which I spent quite a bit of time looking into. It's weird that there's like 10 of them that are designed to run like either directly on a frame buffer or with GTK or on Windows or whatever, but it would be nice if people consolidated their effort and just made one really good one. Generally, the vibe I got, and again, this is 3 years ago when I started this project, things might have changed, but the vibe I got was if you take this on as a dependency, you're going to be maintaining a UI framework, and there are already enough stuff to do, so I decided to avoid that. And then a friend of mine who's an electrical engineer, who also used to work with Sean, funnily enough, he suggested Flutter, which I didn't know anything about, but I'd done a bit of Swift UI, and Flutter looked pretty similar in its sort of, you know, its vibes, being declarative, it seems kind of similar. So yes, if this very early UI that I did, that's kind of around here, was built in Flutter, and then I paid someone that knows how to write. I paid a friend to design something that looked good, and then I someone else to implement it. So basically, there is something interesting though, which I'll tell you a bit about. I'm not going in order here, but one thing I wanted to do is keep all the business logic in Swift. So I wrote, and Flutter has this abstraction which it calls platform channels. Basically, you're just shoving some bytes between the managed Dart world of Flutter and then your native code world. You get an implementation of that on macOS or iOS from the Flutter framework, but I didn't have that on embedded Linux, where we're writing directly to the frame buffer. Well, uses OpenGL, but you know, you take over the whole screen, you don't have all that stuff. So I wrote for this thing called Flutter Swift, which is basically a pure Swift implementation. These platform channels. Uses Codable, something I kind of regret using because Codable's super slow. But it also ties Flutter's event loop in with the native Core Foundation run loop, or on Android, which I'll get to in a sec, with Android native runtime. And there's a fair bit more stuff on Linux. So that's one of the big things. OCA is the control protocol. There's a bunch of other things which I'll touch upon in a bit. And I today updated my stats. Not entirely accurate, but Swift is the majority of code, and by code I mean something that I or someone I've contracted has written specifically for this project, not dependencies. Over the last year, actual lines of code increased by about 35%, but Swift remained constant at around 3/4 of the code in it. So it's only the real kind of very platform specific or real-time stuff. That's in C. And then the UI's increased a bit in percentage terms because it's just got more featureful over the last year. I don't know if I'll bore you about OCA. OCA is just a way of controlling things. It's an audio industry protocol, just an RPC, you know, basically says I pushed a button, and then things that subscribe to that can say, oh, a button was pushed. Well, I'll change my UI. So it's both a thing for signaling, invoking things, and also for getting events. Supported. It's an open standard, so it's supported by a lot of different vendors, and you can build clients that will discover the capabilities of the device and show them a user interface. It was kind of nice. So we use it for everything, and it gives you, kind of a tree view of everything if you want, but you can build your own UI, obviously, and that's what we've done. I touched a bit on Flutter Swift before. One thing I did go on a bit of a rabbit warren, which I just haven't had the time to keep up to date, is porting Flutter Swift to Android. And I was involved with porting the Swift Java, which is Apple's kind of Java native interface bridge for Swift, porting that to Android, which wasn't that hard. It's and more capable people than I are doing it now. But I wanted this app to be able to work cross-platform because, ideally people would be able to, musicians would be able to use a smartphone or a tablet to control the device, as well as touchscreen the device itself. And in this somewhat dated screenshot, which you can see some buttons labeled stress test, which won't be in the final product. But you can see that I'm running in macOS, starting from the bottom right and going counterclockwise in macOS in the iOS simulator. There is, it's running in VMware under Wayland on Linux in the top left, and then in the bottom left, it's running in the Android simulator, and all of that native, all of the business logic code on Android is running in Swift. We wrote a bunch of extensions to integrate Swift to like write a custom executor so you can schedule async tasks on the native Android run loop, integration with Android logging, a whole lot of nice to haves that made it more of a seamless experience. And then the UI is still running in Flutter, but which obviously is natively supported in Android. A little bit of Java code to glue the two things together. That's something I haven't had time to maintain, but hopefully get closer to shipping a product we'll return to. And a few more nerdy bits to finish. Again, it's a bit of a random technical deep dive, but I just tried to pick out the bits that were written in Swift. Linux has a kind of interesting I/O subsystem in the kernel called IOU ring. Unlike things like select, basically, instead of telling you when your read or your write is your socket's ready so that you can do a read or a write on it, it basically does all the I/O for you and it says, hey, you're done. And then it gives you a buffer with the completed I/O if you're reading something. That seemed kind of nice. Actually, I originally used it because Linux has no user space asynchronous support for SPI, which is one of the serial protocols we use. But you could do it with IOU ring because one of the nice things is that if the underlying operation or device doesn't have non-blocking support, then the kernel will spin up a thread, do the I/O for you synchronously, and then still notify you asynchronously when it's done. So that seemed like a nice. There's a guy in a Swift forum that suggested this, but it seemed like a very nice match. This async I/O API matched very nice to async await. So it kind of took me a while to get my head around, but basically we have a little wrapper, which is an async await interface to IOU ring, and effectively when the operation completes, the kernel notifies user space, kind of goes through libdispatch because it needs to monitor a file descriptor, and then registered as basically a pointer in the IOU ring user data is a block, and that block then spawns a Swift task, which either resumes a continuation if it's a one-off operation, or sends data on channel if it's a multi-shot thing, like accepting new clients on a socket. So that all worked pretty nicely, and one of the nice things, you can also coalesce notifications. So if you've got a bunch of things, you can reduce the number of system calls. The general vibe with IOU ring is reduce number of transitions between user and kernel space. We've also got a nice little async I/O wrapper for things like Ranger UARTs and SPI and I2C and GPIOs and all that sort of stuff. So there's, as you probably know with Swift, if you're using structured concurrency, everything has to make forward progress. So whilst it is kind of acceptable to take a lock briefly, or it's probably fine to write to on a serial port to something that's local on your board, but ideally you don't want to do anything that could block. So in order to do that, you need to somehow use some asynchronous I/O. The other thing I've been working on, which was originally started by another person, but I've kind of taken over maintaining, is support for Swift in Yocto. Yocto is super popular and embedded hardware that uses Linux. It's basically like, it's this horrible mess of shell script and Python, but it's like a construction kit for building a custom embedded Linux distro. So instead of maybe starting with something like Debian and just stripping out the bits you don't need, Yocto, you kind of start with nothing, and then you just add in the bits you do need, and you basically have like a build world command, which will build everything from scratch and spit you out an image that you can flash onto your device at the end. So one thing is to add support for Swift to that, so that you can take a Swift PM package and with just a few lines, turn that into a Yocto package. So that's something I have ended up maintaining, but it's really critical part of, because there's so many dependencies, so many packages, it's not possible you really need to be able to build everything from scratch. And there's a bunch of other things I've done. Many of them aren't that interesting, but just integration points with things like systemd on Linux, or we were using for a while Adafruit's seesaw thing for encoders. Now we're using something else, and then integration with Androids, Looper, which I mentioned before. Just lots of random things. Basically, if there was an open source, I've kept, you know, the interesting things that are specific to this hardware proprietary, because I would like to, you know, sell the product and make a few, but eventually anything that's open source, everything else, the infrastructure stuff, I've open source mostly because I'm like, well, if I don't finish this, I want to at least leave some breadcrumbs around that might be useful to someone else. So yeah, that's the sort of random walkthrough, product. I'll go back to the pretty picture.
Nice, I pinched the microphone first. Firstly, I will never misuse the term yak shaving for my own work ever again. What you have gone through is just incredible. When are you coming back for part 2?
Well, I mean, that's one reason, because I'd hoped to do this talk ages ago, but I was like, let me wait until I've got something, you know, in a box, and, you know, it's like, just, I'm hoping to have something. I'd like to have some things in boxes by the middle of the year, but if you think software schedules are hard to estimate, I mean, hardware adds another, it's hard, like, it's, there are tools to debug it, but like, it's, particularly as a non-hardware person, there's just a lot of staring at things. Like, for example, bringing this new display up, like, just doesn't work until you get the things, magic incantations right, and it does work. It's pretty hard to estimate how long it's going to take when it's like 0 or 1. Like, doesn't work or does work, whereas software generally tends to like hold your hand a bit. But I'm hoping that it doesn't answer your question. By the middle of the year, I'd like to at least have a few that I can, you know, get my friends to use.
I'm really curious. You mentioned embedded Swift earlier. I'm not super familiar with it. So what does that cut out compared to regular Swift? And what did you find that you needed? And you mentioned, would you write it in Swift now?
Yeah.
Several years later, would you? And if not, what would you use instead?
Yeah, great questions. Embedded Swift, it does cut out a lot of stuff to do with protocols and generics, which I've used pretty liberally, I think, to minimize the amount of runtime metadata that's in the binary. So that's one thing. I think at the start, the limitations were pretty severe. I don't even know if there was a string type. I think it's really for stuff like you've got a microcontroller and you want to make some LEDs blink. I mean, obviously that's a contrived example, but that kind of stuff where you're just like writing to registers, or maybe it's something you would use inside the kernel, or Apple might use inside the secure enclave or something. And I think they're adding non-embedded features into it bit by bit. But when I looked a few days ago at the list of things that weren't there, they were still pretty significant if you're used to writing Swift, you know, with liberal use. Oh, no async await either. I think that'll come. But I mean, all the things that I use, protocols like type erasure and async await, I mean, I would have to rewrite everything. And well, at that point, you'd have to get to your next question is, what other languages might I have used? I mean, I think it's too complicated to write something like that maintainably in C. Modern C++ is probably a good option, but I'm not familiar with it. I guess I probably would have gone with the cool kids and learnt Rust. I'm not convinced that was a great idea. It would have been a great idea though, because Swift, because of its philosophy of progressive disclosure and some of the decisions it makes about memory management, do make it a lot easier to start just writing code without having to think about things. Whereas my understanding of Rust is you really have to think about things. No, it sounds like it would take some of the fun out. Having said that, I have been using Claude to translate one of the components from Swift to Rust as a bit of an experiment to see if I can, firstly as an experiment only using not actually looking at the code because I don't understand Rust, but also can I just verify that it works from the tests passing. The real goal is to see whether I can get the binary size down, because that's the biggest problem with Swift. Some of these binaries, like, and if that's the only thing on your Swift, on your embedded system, you have to include the runtime cost in it because you can't amortize it against across multiple other things. So these binaries that are statically linked, it's like 40 or 50 meg. If that was written in C, it would probably be like, I don't know, 2 meg or something. And yeah, you know, I'm careful not to use Foundation, so that strips out a bunch of stuff, but it's still pretty easy to pull things in. And I think you have to be pretty aggressive to try and, like, you have to do fancy linker, wizardry to try and get it down. And like I could get this thing down to maybe 11 meg if I compiled in release mode and stripped the binaries. But this is one of the smaller components of the system, and it's still too big for some use cases. But so yeah, Rust would probably be the obvious one, but I don't think it would have been as much fun. The biggest problem with Swift in the embedded world too is that people do think you're a bit nuts, and a lot of the open source stuff I've built that I would hope other people would use, no one wants to touch, because in that community, Swift, no one knows Swift. So that's a little bit sad, because I've open sourced stuff that even doesn't need, even if you want to use it, it's weird. I feel like this doesn't exist with Go, whereas, like if a program only exists in Go, I remember downloading something, I don't know anything about Go, but I can at least follow the instructions. I feel like Swift still has a bit of a smell about it, particularly on non-Apple platforms, that it's, I don't know, it's just not going to work or something, or it's not going to be maintained, or it doesn't work on Linux. I mean, it works great on Linux, apart from the aforementioned issues. So that's a bit of a, whereas people love Rust because doesn't have that perceived tie to Apple, and Microsoft's using it, and yada yada. So I don't know.
I think another question at the front.
Hey.
Yo, so really good talk. Got a lot out of it. It seemed to be, here's all of this stuff on hard mode.
Yeah.
Whereas for me particularly, it's been a long time since I've touched Linux embedded stuff. Is there an easy approach to getting started?
Great question, because my friend Max, who's designed the hardware, tells me not infrequently that I'm doing this on hard mode, and he's like a hardware designer. And in particular, ironically, choosing things like Swift to him is doing it on hard mode because it's an unusual choice, makes things harder. Ironically, for someone that's not familiar with hardware, some of the embedded Swift stuff, or there's a thing called Swift I/O, you can just buy a little box and you can make some lights blink and stuff and write in Swift, actually provides a pretty nice entry point into hardware. But I guess the classic example, and maybe Paul, you'd have a better knowledge than me, because I did kind of dive into this because I wanted to build something and I didn't care how hard it was going to be. I guess Arduino is probably the classic example of getting into something, without too much, with a sort of, in an easier way. And I did some of that stuff a while ago. I was very fortunate to have someone to help on the hardware side. But yeah, if you wanted to build something like this in easy mode, you could probably build something similar that just ran purely on a Mac or Linux or whatever. The problem is the latency would be it would be several milliseconds, which is not going to be much fun to play music with. So it does, for this particular application, I think it needs hardware support. But for general tinkering, I think it's never been a better time to experiment with hardware, and I think I probably would have benefited from trying to do that first instead of diving into hard mode. But the flip side of that is this board can be made in China for 2 weeks, and sure, it's going to cost you a few $100, and you have to make at least 2. But compared to like 20 years ago, I mean, if it doesn't work out, which this one didn't because there was a mistake on it, well, you just do it again. So it's becoming, the iteration's becoming closer to software. It still costs more money, but it's not like tens of thousands of dollars. So I don't know, I hope that vaguely answered your question.
So just, that's actually a very similar question.
Yeah.
So if this was a Chinese product,
Yes.
it wouldn't have a screen.
Yeah.
You'd be doing it from your phone.
Yes.
And it would be a web page.
Yes. That's a very popular approach actually in this in this world.
Would that have been easier?
I mean, for me, no, because I don't know any. I've got a big blind spot when it comes to anything web related. The last time was like 1995, writing a web page in Notepad. Most people are doing similar stuff. There's like a lot of mixers, not for this use case, but a lot of mixers. In fact, the guy that kind of pioneered this is from Melbourne, but the box is just a black box that you snap your iPad into, and the UI runs on the web as a web. So yeah, that would be. For me, web is a bit of an anathema to me. I don't really like webby things, but And also that would have only solved the UI part. It wouldn't have solved all of the other parts.
Yeah.
I mean, again, using Swift, yeah, maybe you wouldn't need to use Swift, but at the end of the day, you're going to have something that is mixing the audio. That's definitely not going to be done in JavaScript or Swift. It's more likely to be done in embedded Swift at some point.
And that's what you need to run on the device itself.
Yeah, exactly.
For the
Yeah.
latency.
And that's still, like, the UI was a chunk of work. Although, I don't know, I mean, Flutter versus web, I think it's probably, if you're familiar with it, it's probably about the same amount of work. You're still going to need something to glue that to the actual hardware.
Yeah.
And then you're still going to need the hardware. So doing it on hard mode, it did make it harder, but you still need to solve these problems, most of these problems somehow. And part of having the touchscreen in the device is I want to choose a touchscreen. I want something like shitty Android tablet. I want like really nice, bright, 300 ppi display. That's like one. I'm building something ostensibly for myself and my friends. That's a premium. There's no way I can make it cheaply because I'm only going to make a few. So you may as well make the most bougie thing you can. And that's kind of been my goal for the whole thing, because there's no way you can compete with a cheap Chinese product. Because if you couldn't compete with a cheap American product, because it'll be made in much larger volumes.
Yeah. No, it's a fair response. It was just something that kind of entered my mind.
But yeah, the web UI is super popular.
Yeah, and I guess this will make it really hard to clone. So no one's going to try and clone
maybe
it.
like I don't know. It's like you'd probably be stupid to clone it, I guess. But I guess
so you're safe sending it to PCBWay. It's not.
Yeah. I mean, I just sort of think about that a little bit. I mean, but of course the magic's in the software. As long as they never see the software, it's not that big a deal. I have thought a little bit about, how much do I want to lock down the Linux image, because I sort of want people to be able to tinker as well.
Yeah.
But you obviously don't want to, I spent a lot of, even irrespective of the money, I spent a lot of time on it. I'd like to get my investment back.
Just a general question, like, have you ever heard of the Connected Community Hackerspace in Hawthorne? Because there's a lot of engineers there, hardware engineers. Like Andy Gleam, who's the guy who...
Oh, I know Andy from Java. Andy Gelme, is it?
Or Gleam.
I don't know. Yeah, I know him from like 30 years ago.
So he actually created LifeX.
Yes.
And
for a long time.
his advice was to keep that separate, to keep the difference with LifeX was that the firmware was kept here.
Yeah.
So while that was manufactured in China, you didn't have that issue. But just be curious, there's a lot of people that in that group that he knows that could help you. I don't know.
I've been really lucky through to meet some people, both here and overseas, who know. Like Paul is sitting here, and I've met some. I'm not saying I don't need to meet more people, but I've met some people that, particularly with experience in the audio industry, that have been super helpful. And actually, there are some in Melbourne. I mean, obviously, no one is manufacturing stuff here, or I imagine really assembling
there are
stuff.
a couple.
But there's some great audio companies like Melbourne Instruments. There's Freakport. There's Turtle AV. There's I've just discovered this stuff in the last 6 months. There's a burgeoning audio hardware industry here, and everyone has been really helpful. And I mean, I don't know shit from clay really. I'm just learning as I go.
Amazing.
So I'm really impressed how encouraging people are. I think maybe it's because I've had a music career. Maybe it's more interesting or something.
Last question.
Yep.
Two questions?
Are you sharing, writing this down, blogging it, any of this process? I probably won't buy the device, but I'd buy the coffee table book.
It's sort of been on my it's sort of been on my list. Maybe I should. Yeah. Do people read blogs still?
100%.
Okay.
Like, if you wrote any of this, it would definitely be eaten up.
I like writing, so I should.
You had at least 17 sub-talks in those slides.
Yeah.
It was amazing.
We'd watch a video of you just soldering things.
Oh yeah, I don't. Well, it would be a very short video because I'm a terrible solderer. Only in emergencies.
Yeah, just a simple. If you would like to update the embedded Swift, does it offer over-the-air
Yes.
software update?
Yeah. So particularly as someone who might not ship a completely finished product, being able to update stuff is super important. I'm using a thing called Mender, which isn't written in Swift. Actually, ironically, it was written in Go, and they switched to C++ because I think it was just easier to target embedded platforms with. So yeah, over-the-air updates will be supported, and there's a whole lot of Swift integration around that, which I've open sourced. But the short answer is not Swift specific. Every device has an A and a B partition, and you basically blow away the whole, blow away the user's data, but you blow away the read-only whole operating system image when you do an update. It flips a bit in the bootloader that says, hey, load from the B partition if you booted from A, or vice versa. When you successfully boot, then you set a bit saying, okay, I'm going to continue booting from this one, and if it fails, then it just boots from the old one. So that's pretty common, and there's a great open source thing called Mender for doing over-the-air updates, and obviously their business model is sell you a subscription for all of your devices in the field, but that requires that they're connected to the internet, and in the audio world, often devices are not connected to the internet, so firmware updates are going to be done by downloading something from a web page, and I have to write an app, which I haven't written yet, that will flash the device.
Well, thank you, Luke.
Thanks.
That was awesome.
Cheers.